Hi, I'm R.H. Jain, a senior advisor at high school in Minnesota, United States. I work at a lab in the University of Minnesota and analyze blood vessels around the brain with the hope to find an efficient way to create an accurate normal baseline of blood vessels under healthy conditions. This will be helpful in giving timely, accurate, and detailed diagnosis for patients suffering from neurological disorders such as dementia, Alzheimer's disease, and Parkinson's disorder. Similar studies may be helpful for cardiovascular conditions like strokes, hemorrhage, and aneurysm. Focusing on the vasculature around the brain and the vascular signals are key to detect disease mechanisms leading to new treatment opportunities. In this research, I hypothesize that the artery to vein ratio calculated from the living brain scans will be more accurate than the measurements taken from post-mortem samples, which will vary vastly as the blood vessels start to shrink and deteriorate, making it hard to analyze post-mortem. The goal of this research is to obtain measurements and calculate spacing between the blood vessels. I analyzed brain scans of in vivo mice models and collected lengths of arteries and veins, their count, and branching details to map fine scale organization of penetrating arterioles and venules. Using MRS viewer, I documented the coordinates of the penetrating blood vessels reaching certain heights by cutting the cube scan at those heights. Next, I calculated the distance between each and every blood vessel. The measurements collected from different mice samples were similar to each other. In conclusion, the scanning done in vivo of mice using two photon imaging helps in accurate identification of blood vessels as they don't collapse and therefore their true measurements can be obtained. Normal baseline using in vivo scans would be helpful for analysis of vascular anatomy, which highlights the role of vessels in fluid dynamics and how their dysfunction can lead to neurodegeneration.